Let's see here. Austin, would you please read the purpose? Josh, relevance? Success, Lewis?
I will be able to describe the making of light in the sun.
Today's grades, participation with notes. Perhaps I'll come around and check your notes to see that you've done that. Homework 120 is all loaded up on Schoology. You'll be watching some videos in order to answer those homework questions. And we have our grades in 3 and 4 days. So let's see, if today was Monday, that means Tuesday, Wednesday, Thursday, and Friday is going to be the quiz. That's assuming that today's Monday. Is today Monday? I think so. Who knows? Storms vocab. We have all sorts of things. Some of these are kind of different. Some of them you might be familiar with. Main ideas. Andrew, would you please read paragraph number 1?
Lightning travels between clouds or between cloud and ground. Lightning usually takes the shortest path to the ground and shoots the tallest object in the area. The same location can be shown by lightning.
Kyle, number 2.
The electric energy of the butterfly in the plasma globe is trying to get to the ground. The current flows through an invisible gas in the globe. The current makes the gas glow in the screen. It hits the glass and travels to the ground.
Number 3, Zach.
When touched by the glass, you are providing an easier way for the current to go to the ground. So most of the current goes to your fingers, and the stream is right there.
And the next paragraph, Sam.
Shortest route, which the tallest object is.
Carly.
Lightning works like the bright stream of plasma globe and rushes into activity when electric charge penetrates ground and makes the air very hot, up to 500,000 degrees, which makes it glow. Both the plasma globe is cooled and
Next page. Alexa, number 6.
When you touch the fluorescent tubes to the globe, the current flows through the gas inside the tube and makes it glow. The current walks the tube the easiest route to the ground, so if you touch the middle tube, the current leaves the tube and goes into your body. The rush of the tube doesn't get current, lightning is like this. It takes the quickest route to the ground. This is why lightning often hits the tallest objects in the area.
Okay, so some diagrams of clouds and such. We're going to review this a little bit with the notes, but for some reason the tops of clouds get to be positive and the bottoms, right here we have negatives, and there are different theories as to why that happens, but gradually the charges build up enough that we have sparks fly. Just like when you shuffle feet on the carpet and you touch a doorknob, you see a little spark. So here we have another diagram with the positives on top, negatives on the bottom. And when the negatives build up, that creates positive charges on the ground and trees and buildings right below it, and eventually they jump. But we could have lightning jump not between the cloud and ground, but between 2 clouds, or within the same cloud. Okay, part 1, next page. What age group had a third the deaths of 20-year-olds? Which age group has about a third of the deaths by lightning compared to 20-year-olds? So we look here, and 20-year-olds had about 75 deaths during this time period. So a third of that, 75 divided by 3 is going to be 25. So which bar is about 25 high? And that's going to be 60-year-olds. What age group had 4 times the deaths of 70-year-olds? Okay, here's 70. Going across, that looks like about 12 to 15. I can't quite tell exactly. But 4 times that. 4 times 12 is 48, or about 50 of them. So I'm going to go up to 50. And it's going to be like the 30s. Yep, the 30-year-olds. So we're taking 12 here as the number for the 70-year-olds, multiplying that by 4 times. That gets us 48, which is the 30-year-olds there. What fraction of all deaths were 20-year-olds? Fractions of all deaths. So we have the 20-year-olds on top and all deaths on the bottom. We just said a few moments ago the 20-year-olds had 75 deaths. What's all the deaths? Well, we have about 9 there. The next one is about 58. The next one 75. The next one we said was about 48. The next one about 60. The next one about 55. And the next one is about 28. Let's estimate this one to be 28. And then we have about 12 for the 70-year-olds. And maybe 2 or 3 for the 80-year-olds. Let's say 2. And we add all these up. Holy cow, that's a lot of numbers. Let's add these up with the calculator. So we have 9 plus 58 plus 75 plus 48 plus 60 plus 55 plus 28 plus 12 plus 2. So there's 347 total deaths. So there's our fraction, 75 over 347. Let's round that to get a slightly nicer number of some sorts. If I just called that 70 and I called the bottom 350, just kind of rounding them to more familiar, friendly numbers. 7 goes into 35 5 times. So 70 is going to go into 350 5 times. So I can reduce this to 1/5. About 1/5 of the deaths by lightning occur to 20-year-olds. Alrighty, let's have our phones away, please. Phones away. We'll go on to the notes after everybody's phone is away. Put them in your pocket or your purse or your backpack, not in your table and not on your lap, please. Not on your lap, please. Okay. Clouds get charged due to a storm at the top, so the cloud is positive and the bottom is negative. The exact reason for this is not certain, but it might be due to particles in the clouds rubbing against each other. When the charges build up enough, sparks fly. Just like you rub your feet on the carpet and touch a doorknob. The charges may fly within the cloud, between clouds, or between the cloud and the ground. Each lightning bolt might actually be several back and forths. Several bolts, back and forth jolts. Up and down, 6, maybe even more times. And it looks to us like just one flash because it's so fast. Lightning naturally flies to find opposite charges. Because one is pushing, one's pulling. The negative charges are pulled by the positive charges, so they attract. It generally finds the shortest path. What should you do to avoid being hit by lightning? Don't stand by trees or other tall things. Telephone poles, TV antennas, or whatever. Don't stand next to those because it generally finds the shortest path, which is going to be the tallest object, from the cloud down to the tallest object. Number 6, can you survive being hit by lightning? Yes, lots of people do. It is not a death sentence, although a lot of people do die from it too. Should you talk on a landline during a thunderstorm? Now, a landline, by that I mean the telephone with a cord that's attached to the wall. You know, when I started to teach this, I came here 15 years ago, cell phones were just coming into use a lot. Of course, they had cell phones before that, but in terms of popularity and affordability, they were just getting common. And about half the people had the telephones with cords attached to the wall. I don't know, does anybody have such a phone anymore? Even the landlines have cordless phones where you can walk around your house, and then you put it back in the little docking station to charge up. Does anybody have a phone with a cord? Wow. Okay. Well, the answer to this is no, you should not, because lightning can strike the telephone poles outside your house and transmit that current, that huge current, all the way down the line and hit your phone and hit you and do bad things. Can you talk on a cell phone or a cordless phone during a thunderstorm and be safe? Yes. There's no connection between you and the lightning bolts outside, so it's safe. Some buildings have lightning rods on the top connected to the ground by a thick metal cable. These allow lightning to get to the ground safely without going through the structure and destroying the things on the inside. So here you see what's on the top, just a little spiky thing. And then here you see a close-up of the bottom of the spiky thing with this big cable, about as big around as your thumb. And then that cable goes down to the ground. And here's what can happen to a tree. So you don't want that to happen to the 2x4s in your house when a lightning bolt goes through the 2x4s. So this cable over here allows a safer route for the lightning to go around the 2x4s. And here's a picture of a church that's on fire because the lightning bolt hit it. The wood gets so hot that it bursts into flame. Please have your heads up, please. Heads up, heads up, heads up. Thank you. Thunder. Air heats up to the ground about, we're going to say about 50,000 degrees, but we're not going to get exact picky. You might see some sources say 30,000, some say 60,000. It's just in the tens of thousands of degrees. I want you to know that it's not millions of degrees, and it's not hundreds of degrees. So on a quiz, I might ask you a question of, what's the temperature of a lightning bolt? Is it 300 degrees, 30,000 degrees, or 3 million degrees? And you need to know it's the 30,000 kind of a thing. Or I might say, is it 500? Is it 50,000? Is it 5 million? You just need to know the basic size of the number, not the exact number. This heating causes very quick expansion. We've learned in the past that as things get hot, they expand. So the water here, the air, quickly heating to 50,000 degrees is going to very quickly heat up, and that expands and vibrates. We hear that as thunder. When the light of lightning travels, it's virtually instantaneous. The sound travels, though, much slower. The light travels at about 300 million meters every second. That's like 3 million kilometers a second. Something. I can't do the math in my head. But it's really fast! 3 million miles an hour, something like that. No, 187,000 miles per second. That's the exact number. I'll say that again. The light travels at 187,000 miles per second. Sound travels much slower. It takes about 5 seconds for it to travel 1 mile. 1 mile, 5 seconds. The more delayed difference then between the lightning and the thunder means more distance away from us. For every 5 seconds, the thunder is a mile away. Why is some thunder sharp and quick while others are long and rumbly? So here's the ground, here's a tree, here's you, here's the cloud. If the lightning bolt is like this, each little section of the lightning bolt as it zigs and zags is going to give off a little bit of thunder, and the thunderclap from the top section is going to hit us just as fast as the one on the bottom. However, if you have a situation like this, where you have the lightning coming from this cloud, and it is going like this little bit of thunder is going to hit you a lot faster than this bit of thunder from way up high. This might be 2 miles long. There was one poor old guy. He was in Florida. It was a nice sunny day. He wanted to have a barbecue, so he went out to his back deck and he was grilling up some burgers or something. Please put your phones away at this time. Put them in your purse or your backpack, not on your lap. So this guy was just grilling. It was a sunny day. There were a few clouds, but they were like way over there. So he was grilling. Kaboom! Lightning bolt from 5 miles away. Hits him, kills him. So that was very, very horizontal like this. Okay, hail. Sometimes hail develops in a thunderstorm when there are severe upwinds, updrafts. Winds blowing upwards. These push raindrops very high where they freeze.
I don't get what that picture is something.
This one right here?
Well,
This one here?
no. The people are rubbing that in. What is that?
This is a tree. This is you. Thundercloud. Lightning bolt. Ground. Okay, so these updrafts, winds going straight up, push up raindrops where they get really cold and they freeze, and they can sometimes be suspended up there. As these updrafts push up on it all the time, the longer that they stay pushed up, the more they grow and they get heavier and heavier, and pretty soon those heavy frozen raindrops can't be held up anymore by the wind, and so they fall downwards, and we see that as hail. Why do storms happen often at night? It is not completely understood, but it's thought that at night the upper air cools faster than the lower air. So the cooler air sinks, forcing moist air near the ground to go up. So we get this up and down currents, and that makes clouds. And if the clouds get big enough, thunderstorms. I'll pause there for a second. Anybody need more time? Alrighty. Radar to detect storms. Radar works by sending out radio waves and listening for their echoes. Find the website for current and projected radar from the National Weather Service at www.weather.com. Okay, let me try to bring that up here. www.weather.gov. Okay, there we go. Note the tab on the left side that says Active Alerts and the middle called Radar. Where does it say that? It says here on the left side. Oh, they've changed their website. It's not there anymore. Home forecast past weather information. Is there a radar here?
Right there.
Radio.
I think you're
Safety. Past weather. Let's do forecast.
Okay, we're gonna want to figure it out.
Yep. Okay. Wes, did you see it?
Yep.
Okay. Can you direct my mouse left, right, up, down?
He doesn't know his left and right.
I do know what that's
You want to come on down, Wes, and do it yourself?
Look a little bit down. It's right under there. It's right there.
Radar, hot diggity dog.
You've been looking at it for
Okay. So there we can see all sorts of radar stations all around the country pool their data together, they combine it in the computers, and there they got it. Okay, so this is not just one big radar station that covers the entire country is what I'm getting at. Okay, so the time that it takes, let me get the... Okay, the time that it takes the echo to return, the farther away the item is. So this tower here sends out a radio beam, and that bounces off the clouds and the rain, and the computers here can tell how long it takes for that bouncing reflection to happen. Doppler radar also tells the speed of the objects, the speed of the raindrops and the winds. The way they do that is by listening to the pitches, so to speak, of the radio waves. Think to yourself about a race car. What would it sound like if you were trying to mimic a race car going past you? You'd do something like, so the pitch goes down as you pretend that the race car goes past you. Race car sounds go down as the car goes away from you. So objects that are moving away from the radar dish will cause a radio signal to go to a lower frequency. Objects that are moving towards the radar dish will go to a higher frequency, and the computer can tell what the frequencies are and therefore determine how fast it's going towards you or away from you. So let's see if we can find the Doppler radar here. That was on the previous screen. Now in this case, the darker the colors means more rain. Now let's go to Doppler radar. Let's see, was that the only one? Oh, this is Doppler radar. It's not showing what I was expecting it to show. Let's go on with life. Number 23, objects, we did that. 24, 25, if the National Weather Service issues a severe weather blanket, means that conditions exist that could create dangers. It's not exactly now, but it could, so you just got to keep a watch out for it. It might happen, it might not. But if we issue a severe warning, then we know that there is indeed danger right now. I'm telling you, it exists. So you got to take action. On a weather map, severe rain can be seen as red areas. Areas of which may be warning may be shown as a square or some kind of a rectangle. So here they have a trapezoid showing the area in which things are being alerted. And that's the end. We have homework 120. You have a video there to look at. Notice that I have here that in the first minute you answer that question. The second minute of the video has the other questions. Then we have another video here, and another one down there. And that's the end for the required stuff. Here we have a couple more fun videos. 10 people struck by lightning, 5 people who were struck by lightning, and the 10 best lightning strikes, if you want to see those afterwards. But those questions are loaded up in Schoology right now.